Hi everyone, this video is for Algebra 2 and it's just going to cover the material from yesterday's lesson that we didn't get to. So we started off talking about real numbers, what the different categories are for the numbers, and then we looked at how to put them on a number line. So we have two more things that we want to get to in this unit. The first one is going to be what the key properties are for real numbers. And then we'll talk about unit conversion, so just how we use different types of units in applied problems that involve real numbers. So this is the same PowerPoint that we had yesterday. We filled in the subsets of our real numbers. We talked about why that's important. We graphed the numbers on a number line, looking at what to pay attention to with the square root values, what to pay attention to with fractions, and so on. So the next thing that we want to get into, and that you can find on your beige handout if that's what you're using for your notes, are the properties of real numbers. So when it comes to properties, we just want to be aware of what types of operations are okay to perform for real numbers, and specifically for addition and for multiplication, what operations are okay to do. The first property that we want to learn about is called the closure property. And it's something that seems a little bit obvious at first. The closure property for addition just tells you that if you take two real numbers, so two basic real numbers might be, oops, my pen's not working here, 2 plus 6, you end up with the number 8. So what we want to look at here is the fact that 2 and 6 are real numbers and 8 is a real number. So if you take two real numbers and add them together, you get a real number. Same thing with multiplication. If I take two real numbers, 2 times 6, and I get 12, 12 is also a real number. So that seems really obvious, I'm sure, but the one thing that we talked about with real numbers yesterday is the fact that they're not imaginary. So we mentioned that imaginary numbers are something that we'll get into in this course at a later point in time. So this closure property is something that we'll come back to, and we'll see how it's a little bit different with imaginary numbers. So at this time, all that we want to pay attention to is if we add or subtract real numbers, we still end up with real numbers. Really simple. Next up, we have what's known as the commutative property. When you think commutative property, I want you to just think of the fact that order doesn't matter when you're adding or multiplying numbers. So let's go with two new numbers. Let's deal with 3 and 5. So if I add 3 and 5, it doesn't matter if I reversed that order and added 5 and 3. Either way, I'm going to get the same answer. I'm going to get that 8 is equal to 8. That also applies to multiplication. If I take 3 and I multiply it by 5, that's the exact same thing that I would get if I take 5 and multiply it by 3. They're both going to be equal to 15. The order does not matter. Now, the commutative property applies to multiplication, it applies to addition, but not to subtraction, and not, skipped forward a slide, and not to division. So order does matter for those two operations, and that's something we need to keep in mind when we solve more complex equations, so that the order does matter for those two operations. So then let's jump on forward and talk about two more properties, the associative property and the identity property. So for the associative property, you want to check out this first part of the word, to associate. So when you think association, I want you to think about groups. So when we talk about groups for addition and multiplication, that's one of those things where, again, the order is not going to affect the outcome of the operation. So let's give ourselves three new numbers. Let's talk about adding 1 plus 2 and 3. So notice how right now I have groupings around 1 and 2. But if I grouped this differently, if I said 1 plus 2 plus 3, that's not going to change the outcome of this operation. So when I read this, anytime I'm working with math, I have to follow order of operations, which tells me to go to the parentheses first. So this is telling me to add 1 and 2, which is going to give me 3. And I'll have 3 plus 3, which is going to give me 6. If I came to the other side, I'm going to get 2 plus 3. That's going to give me 5. If I add 1 and 5, I'm going to get 6. Either way, same answer. So the grouping does not matter, in the same way that the order didn't matter on the previous slide. With multiplication, I have that same effect. So if I have 2, and then inside of the parentheses, I have 3 times 4, that's going to give me the same answer as if I put my parentheses out in front and had 2 times 3 times 4. So in this instance, 3 times 4 would give me 12, times 2, that's going to give me 24. Notice that I'm doing the operation in parentheses first, no matter what. Over here, 2 times 3 is going to give me 6. 6 times 4, that's going to give me 24. So the grouping doesn't matter for my multiplication here. Again, you want to be able to identify the properties based off of what's going on in the problem. So if you see parentheses grouping values in different ways, but it's not changing the outcome, you're definitely dealing with the associative property. So next up, we've got the identity property. When you think about the identity property, you want to think about numbers maintaining their identity. So that means that they're not going to change. So let's say I start off with the number 7. If I don't want the number 7 to change when it comes to addition, the number that I add to it is just going to be 0. So anytime you add 0 to a number, it maintains its identity. It stays the same. That's all that the identity property is. And then for multiplication, if I have the number 7 and I want it to stay the same, I'm just going to multiply it by 1. So 7 times 1, still 7. It's retained its identity. We've got 2 more properties to talk about, and then we'll be all done here. So the inverse property is one that can easily be confused with the identity properties. You want to watch out that you don't confuse those two. Let's give ourselves another number to consider for addition. So let's start out with the number 10. When you think about addition, we deal with what is called the additive inverse. So the additive inverse is just going to be whatever number you add to get a given value back to 0. So if I have 10, if I want to get 10 to 0, I'm just going to add the number -10. That's my additive inverse. It's just going to reduce a number from its value to 0. Now, when it comes to multiplication, the multiplicative inverse is a little bit different. With the multiplicative inverse, we're not trying to get back to 0, but we actually want to get back to 1. So let's say, in this case, I start with the number 20. If I want to get 20 to the number 1, I'm going to multiply it by 1 over 20. And the reason for that is if I think about this as fractions, oops, did I just lose my pen? There we go. I'm going to end up with 20 over 20, which is equal to 1. So anytime I'm dealing with a multiplicative inverse, I'm really just flipping my fraction upside down. So if you see something like 3/4, that multiplicative inverse is just going to be 4/3. We're flipping the fraction over. So a little bit different between adding an inverse, so what that looks like, and a multiplying inverse over here. The last property that we have is the distributive property, and that's going to deal both with addition and with multiplication. So I'll just combine these across my boxes here. So let's say I have a setup like 3 times 5, 5 plus 1. This expression I can either solve by adding together what's inside first, or I can distribute the 3. So the 3 can go to the 5 and to the 1. So this will give me 3 times 5 plus 3 times 1, or 15 plus 3, which is equal to 18. So the distributive property just tells me that if I have multiplication outside of the parentheses where there's addition inside, then I can go ahead and take whatever is being multiplied outside and apply it to each of the numbers inside. So that's all that distributing is. Those are all of the properties of real numbers. So the next thing that we want to touch on is the fact that much of the work that we'll do in math is going to be useful for scientific application. So that could come into play in chemistry or physics. Economics is more of a social science, but still something where we'll see a lot of math applications. So we want to make sure that we can do unit conversion. So that whatever units were given in a problem, when you think units, you want to think measurement, like feet and seconds, things like that. So we want to perform those conversions pretty quickly. So let's take a look here. This problem says to convert 60 miles per hour to feet per second. So our first quantity is this 60 miles per hour. So if I write that out, 60, when I talk about miles per hour, I'm going to write that as a fraction. So the per tells me that the miles is divided. So I want to convert this ultimately into feet per second. So to do unit conversions, I need to think about how to get rid of the units that I have and get into the units that I want. Now the two units we begin with are miles and hours. It doesn't matter which one you want to get rid of first, you'll have to get rid of both of them at some point. So let's begin by getting rid of miles. If we're trying to go from miles to feet, we need to think about how many feet are in a mile. And these kinds of things you may memorize over time the more applied problems you do. But you can also just Google that, feet in a mile. And if you do, you'll find out that there are 5,280 feet in 1 mile. So notice that now I have miles in the top of this fraction and miles in the bottom of this fraction. And if I have the same thing top and bottom, they will cancel out in any kind of math work. So I know that I'm good to go converting from miles to feet. So the next thing that I need to do is to go from hours into seconds. You might not know off the top of your head how many seconds there are in an hour, but you might be able to go into minutes. So let's try doing that. If I think about hours, there are going to be 60 minutes in 1 hour. Now notice my hour is up top because this value for hours was down below and I want them to cancel out ultimately. So now I'm going to be left with feet per minute. So I need to do one more calculation step and I need to get from minutes into seconds. So in 1 minute, there are also 60 seconds. So let's just double check that our unit values are going to cancel out here. The miles will go away, the hours will go away, the minutes will go away, and we're going to be left with feet per second, which is what we're aiming for here. So now this just becomes a multiplication and division process. I'm going to multiply the values across up top, so 60 multiplied by 5,280, and then I'm going to divide by what's below, so 60 and 60. So go ahead and try plugging that into your calculator, and I'll do the same thing. So if I multiply 60 by 5,280, I get a big number, 316,800, and then I divide that by 60 times 60, and I end up with the value of 88. So my final units are 88 feet per second. So 60 miles an hour is the same thing as 88 feet per second. They're just different units. And that's how you do your unit analysis work. So then we want to go ahead and try one more. This problem says, Connie decides to work abroad in Paris for her summer internship, where she'll be paid in euros. Her employer tells her that she'll make 350 euros per week, and this sign should actually be an E for euros. For a standard 40-hour work week, what would this be in dollars per hour? So, as Americans, we think about things better in dollars per hour, but Connie's employer tells her her salary in euros per week. So let's go ahead and do that unit analysis. We've got 350 euros in 1 week. And euros are the currency that they use in every country in the European Union. So the first value that I might want to get rid of are euros. So I'm trying to go from euros into dollars. So that means I'm going to want dollars up top and euros down below. So for this kind of conversion, I probably want to go ahead and look up online euros to dollars and that conversion rate. So $1 is equivalent to 0.88 euros. So if I look that up, I'm going to have $1 and 0.88 euros. So notice now that my euro units are going to cancel. So now I'm in dollars per week. So then I just